Olga is a future doctor, and Satya is co-hosting. She's a future lawyer. Is that cool? So we have the future with us today. All right, ready? It's almost 7 o'clock. Ready, set, go. Everyone, thank you so much. I'm so happy you're in this webinar. My name is Frances Kweller. We are going to get started right away. I want to take a moment to extend my deepest gratitude to Olga. Thank you so much for doing this, for hosting. It means so much to all of us. Thank you for all the colors and the blue, especially that color and the pop. I really want to take a moment to say that I know that you're putting a lot of hearts into these webinars, and it just means so much that you're doing this. Without further ado, it is 7 p.m. So we're going to get started. The group is probably going to be smaller because there is quite an open house today. So I think that a few will be missing. We will miss you. These webinars are also recorded. Let's get started. Okay, I will be on mute and I'm going to close my video as well. Okay, go right ahead, Olga. Thank you.
Okay. Hi guys, nice to see all of you again virtually. Welcome to our second webinar this week. So yesterday we went over reading comprehension. We focused on strategies and we did a deep dive into the real released SHSAT Form A that you guys all should practice multiple times. So yesterday we worked out of that exam to do reading comprehension. Today, the plan is for the first hour, I want to do like a very comprehensive review of the math section, not so much teaching you guys specific things, but more teaching you guys things that you need to like know, need to have memorized, need to have in your brain before the exam, because the exam doesn't come with any sort of formula sheet and the exam doesn't allow you to use calculators. So there's certain strategies that we can teach you guys for you to be very, very well prepared for this exam. Certain things that if you know, you memorize, you practice, once you see them on the exam, it'll be a lot easier. So that's the goal for the first hour. So that's what I'll do between 7 to 8. And you guys can follow along. Please take notes. And as always, we'll be able to send out both a recording and a PDF of the notes after the webinar. And then for the last hour, we'll work out of that same exam that we started yesterday, but through the math section. And I'll show you guys how to use those strategies that we talked about and how to actually apply them to the different questions, both the fill-in questions and the multiple choice. So that's kind of the plan. So everybody's aware, and we're going to kind of get straight into it. And if anybody has any questions at any time, you guys know to just put them in the chat and I'll be monitoring it as we go along. Okay, so the first thing that I want to talk to you guys about in terms of things to memorize, or it's just formulas or review, I want to start with a review of geometry. So let's do that. So this test is really big. They like testing geometry in all categories, but importantly, I want to focus on triangles, circles, and angles. So let's start with, what do you guys want to start with? Triangle, circle, or angles?
Everyone type into the chat. I just want to compliment you. I actually thought the attendance would be much smaller today because I know there's an open house. So I'm really happy to see we're so high today. All right, go ahead. Please type what you want into the chat.
We got a lot of requests for circle. We're going to do both circles and triangles. It's just which one's first. So circles came in first. So let's start with circles. Okay, so for circles, the things that you guys need to know 100% is the formulas for the area of a circle and the circumference of a circle. So I'm going to put these up and you guys can beat me and start putting them in the chat just to test yourself. So the formula for circumference in a circle is 2 pi r, which is the same thing as pi times the diameter. So just to be perfectly clear, whenever I teach geometry, I like using shapes. So you guys can see exactly what we're talking about. So here's a basic circle. Here's our center point. This line from the center point to any outside edge of the circle is called the radius. And then a line that goes from one edge through the center all the way to the other edge is called the diameter, right? These are basics just for your guys' review. And you should know that there's a relationship between the radius and the diameter. So that relationship is a diameter is 2 times the radius, which is why both of these formulas are true for the circumference. And the way that you guys should all think about circumference is it's kind of like the perimeter of a circle, but because a circle is a different shape, it gets its own special name. So imagine taking a string and going all the way around in the circle like this, and then unraveling that string and measuring it. That's what you're doing when you're thinking about circumference. So that's where what the sort of conception is behind circumference. That's what I want you guys to think about. Okay, so that's circumference. Then we also need to understand area. And like you guys already put into the chat, the area formula is pi r squared. Good. Now, a lot of times on the test, they'll keep things in the answer choices in terms of pi, which is nice for us because it saves us some math, but sometimes they don't. So you guys need to know what pi is as a fraction and as a decimal. So as a fraction, pi is 22/7. And as a decimal, it's approximately 3.14. It keeps going, but that's good enough for you guys to know, 3.14. And this is important to know both as a fraction and as a decimal, because sometimes your answer will be in terms of a decimal, and it's a lot easier to simplify if you know pi in terms of a decimal instead of having to spend time doing that conversion. So this is something that I would say that you guys need to have memorized for the test, these values, that pi is 3.14 and pi is 22/7. Okay, so the other thing that I want to talk about in terms of circles is what is the sum of angles in a circle? How many degrees is a circle? Good, 360 degrees. Good. And the reason that's important is because this is a very common question that I'm going to review with you. This is something that they can ask you. They can draw you a circle. And they can say, let's say the radius is 10. And then they can say, let's say this is 45 degrees. And what they can do is they can ask you the area of just this section, just this highlighted section. And how would you guys tackle a question like this? Good. So basically what I want you guys to understand here is that this section, 45 degrees, is some proportion out of the full circle. So here we're combining what we learn about geometry and circles with things that you've learned in the past. So things like proportions and ratios, right? So what you need to do is you need to know that 45 out of 360 is going to be the proportion of this area, this highlighted area, which I don't know, I'm going to call it X, over the area of the circle, which we just went over on the top, right? The area of the circle is pi r squared, so pi r squared. But instead of keeping this as r, we know the radius, so we can just plug that in. So this would be 45 out of 360 is equal to x over 10 squared pi. 45 out of 360 is equal to x over 100 pi. And then you just cross multiply and solve this, right? So the difficult part that I want you guys to understand is understanding how they combine the different things that we learn, right? Because a lot of you guys know all these formulas and a lot of you guys know proportions, but I want to make that bridge for you guys that they can intercalate these things when they test you. So it could be a question that looks like it's just on circles, but you need to do both. You need to know those formulas and you need to be able to apply proportions in order to solve that problem. And I also want to show you guys that the same exact thing is true. They might not only ask you for the area, they could also ask you for the length of this, and you would do the same thing, but you would just make the proportion to the circumference. Does that make sense to everybody? So the takeaway here is proportions with angle out of 360 degrees. Okay, so that's kind of like the main summary of circle things. Another category of circles that they can ask you about is regular polygons inscribed in circles. So let's switch gears a little bit to regular polygons, and then we'll go to triangles. So what do you guys know about regular polygons? If they tell you the word regular polygon, what does that tell you right away? Yeah, so by definition, in a regular polygon, all the sides and angles are equivalent, they're congruent. So that's a big definition that you guys need to know, because they sometimes won't tell you that the sides are equal. They'll just tell you it's a regular polygon. So by definition, you need to know that if they use that language, regular polygon, they're telling you all the sides and all the angles are equal. Okay, so all sides and angles are equal. So how do I figure out if I give you guys a hexagon like this, and I tell you this is a regular polygon, right? This is a regular hexagon. You guys know that all of these sides are equal and all of these angles are equal. But can you guys tell me what is one of those angles? How do I find what one of those angles are? So there's actually a formula, and the formula can tell you the sum of angles in any polygon. So sum of angles in any polygon. And this formula is another one that you guys absolutely need to know for the test. And this is the formula, n-2 multiplied by 180. So I'm going to highlight this for us because it's another important one. And n here stands for the number of sides in your polygon. So you can do this to any polygon. We can do this to a hexagon, to an octagon, to a decagon, to a dodecagon, and so on and so forth. But on the test, usually I don't really see them go past 10. Usually they like sticking to like hexagons, octagons, just for you guys to know. But technically the formula will work for anything. So in this case, if I'm asking you guys about a hexagon, what would my n be? Good, yeah, my n would be 6. So let's go ahead and plug it in. So it's going to be 6 minus 2 times 180. So that's 4 times 180. And what's that going to give me? Good, 720 degrees. So I just figured out that the sum of all the angles is 720 degrees. And I know that all the angles are equal. So how do I find just one angle? Exactly. So somebody put it in the chat. If you wanted to find the angle of one side, you divide by the n. In this case, it's 6. So one of the angles, so let's call this angle A. So then angle A is going to equal 720 degrees divided by 6. And that's going to give us the answer, which is, what did you guys get? 120. Good. So now we just figured out that all of these angles are 120. So this is 120, and this is 120, and this is 120, and this is 120. They're all 120. That was the goal of the calculation. This formula is to give you the sum of angles in any polygon, but it'll only, if you want to find one of the specific angles, it'll only work for a regular polygon, because obviously then they're all equal. But if they didn't tell you it's a regular hexagon, all I know is that all the angles have to add up to 720, but they don't each have to be 120. Does that make sense? To answer your question. And now again, the way that they can test you is they might not necessarily ask you for angle A. They might extend this a little bit, and they might call this angle B and ask you what that is. But the way you figure it out is you get angle A, and then you know that this is a straight line, and all straight lines are supplementary or add up to 180, and then you can figure out, okay, well, this has to be 60. Does that make sense? So again, I'm trying to teach you the different ways that they can come at you with these questions, but I want you guys to think about it systematically. If you see the words regular polygon in a question, like 98%, they want you to use this formula. And maybe that won't be the final answer, but that will be a step to get you to the final answer that they want, that you'll have to go through this process. You'll have to use this formula. You'll have to get each one of those angles, and then you're able to go forward. Another thing they can do is they can start connecting these polygons to, oh, somebody said, where did I get 60 for B? Okay, so if we zoom in here, you see that A and B are one straight line, right? So all straight lines have our angle 180, right? This is called supplementary. So because I know that this is a straight line and they add up to 180, and I figured out that this is 120, then this has to be 60. Does that make sense to answer your question? Okay, so sometimes they start connecting these polygons, these polygon types of questions with triangles. So triangles is another really big topic on this test. I'm going to create a new page for us and we'll do everything triangles. All right, so we'll start with the basics and then we'll get a little bit more complicated. So let's start very basic. If I draw you a triangle, what do you guys know about the sum of angles in a triangle? Good. Good. So this one is easy, right? Sum of angles in any triangle is 180 degrees. Good. Now, what do we know about the relationships of sides? So what if I say that this is 7 and this is 4? What can you tell me about this last side, y? So the way that this works is that it has to be between the range of the other two sides. So what I mean is that y has to be somewhere between the difference of the other two sides and the sum of the other two sides. So y has to be somewhere between 7 minus 4 and 7 plus 4. So it has to be somewhere between 3 and 11. And it does not include 3 and it does not include 11. So it can be 3.0001 or it can be 10.99999, but it can't be 3 and it can't be 11 itself. Does that make sense? So sometimes they'll ask you which of the following could be the third side of the triangle, and they'll give you options. So let's say that was the question here, right? They'll say which of the following could be the length of side y. And they'll give you options. They'll say A is 2, B is 12, C is 11, and D is 6. And then obviously, since we just went over, it has to be within this range. So the best answer here is going to be obviously choice D. Good. So that's kind of very, very, very basics of triangles. Other things that we can talk about is perimeter of any triangle is just you add up all the sides, same as any other shape. And then what about area of a triangle? Yeah, 1/2 base times height. Okay, good. So again, these are sort of the basics. Now let's talk about Pythagorean theorem. Okay, so what kind of triangle does Pythagorean theorem apply to? Good. So that's really important. So you can only use Pythagorean theorem for a right triangle, only. So right triangle, of course, makes sense. This one angle has to be 90 degrees. So only for right triangles. Okay, and then what is Pythagorean theorem? Good, excellent. So Pythagorean theorem is a squared plus b squared equals c squared. Another formula that you guys absolutely have to know for this test. And which one is c? Which side is c? Good, so this has to be hypotenuse. And the way that I want you guys to define hypotenuse in your head is it's the longest side of the right triangle. And it's always diagonal or across the 90-degree angle. So longest side across 90 degrees. So in this case, this is my hypotenuse. So this is my C, and these two are interchangeable. It doesn't matter for the formula which one you label as A and which one you label as B. Does that make sense to everybody? Now, you have to go beyond just knowing this formula because there are special triplets, right? They're called Pythagorean triplets, and I want you guys to memorize them. No, it's not inclusive. We'll add that to the notes. Okay, so let's talk about the special triplets. Do you guys know them? Yeah, 3, 4, 5. Any other ones? 5, 12, 13. Good. Okay, let's write them down. Pythagorean triplets. Okay, so you guys already said 3, 4, 5. So this column is going to be for hypotenuse. And these are going to be legs. Leg 1, leg 2. Okay, 3, 4, 5. You guys also said 5, 12, 13. There's also 8, 15, 17, and 7, 24, and 25. And I haven't really seen them go above that, but these are the ones that you really need to know. But it goes a little bit beyond that, because you have to know not just these. So you absolutely have to memorize these. These are your bases, right? That these are the triplets. But you also have to know that any multiple of these is true. So that's how they that's how you really, I'll show you guys. So any multiple of these is true. So if I decide to multiply 3, 4, 5 by 2, 6, 8, 10 is a triplet. If I want to multiply it by 3, 9, 12, 15 is a triplet. If I want to multiply it by 10, 30, 40, 50 is a triplet. And that's true for any of these, right? So this can be 10, 24, 26. It can be 50, 120, 130. Same thing here. We can do 16, 30, 34. Same thing here. We can do 14, 48, 50, right? Do you guys see what I'm saying? Now, for people that are confused about what a triplet is, let me show you. So if you have a right triangle and they're going to ask you, what is B, right? That's the question. What is B? And then they'll label this as 3 and they'll label this as 5. All of you know that you can just put this into Pythagorean theorem, right? So all of you can say 3 squared plus b squared is 5 squared, and you can do the math. 9 plus b squared is 25. And you can subtract 9 from both sides and say b squared is 16 and take the square root and say, okay, b has to be 4. But all of this is a waste of time because you guys should know that 3, 4, 5 is a triplet. So when you see a 3 and you see a 5 and the 5 is the hypotenuse, you should automatically know that the last side is a 4. Does that make sense? And you don't have to go through this work. And now this work is not so hard because 3 squared and 5 squared is easy. But if you guys are dealing with 16, 30, and 34, you're going to waste so much time squaring 30, squaring 34, doing the arithmetic. And not only are you going to spend time doing that, but you expose yourself to potentially making a mistake because when you're doing all that arithmetic, you can potentially make like a arithmetic mistake. You can subtract wrong, and then everything after that gets messed up. And the way that you know if something is a Pythagorean triplet is you memorize the common ones. There's infinite amounts, but these are the really common ones that I've seen come up on the test. So these are the ones that I would recommend that you memorize, especially the highlighted ones. Not so much the ones in green, but the highlighted ones, because the ones in green just come from the highlighted ones. They're just multiples of them. Does that make sense to everybody? Okay, good. Now, the other thing with triangles that I want to talk about is the special right triangles. So do you guys know there's two that you should know? What are the special right triangles? Good. 45, 45, 90 and 30, 60, 90. Good. Good. So let's review those together. So let me draw us one. Okay, so let's say this is 30 and this is 60 and this is obviously 90. So what you guys need to know is that if you see a right triangle and it's a 30, 60, 90 triangle, there is a special relationship of the sides that you guys have to have memorized. So that relationship says that across the 30-degree angle is a side. We will call that side X. Across the 90-degree angle is whatever is across the 30 degrees times 2. So this is going to be 2x. And then across the 60 degrees is going to be x radical 3. So for people that this may be new to, let's do an example. So let's say they say, what is side Z? And they give us this triangle. And that's all they tell us. So from this, I'm going to zoom in here, right? So from this, we can automatically extrapolate that we have a 30, 60, 90 triangle, right? They didn't label the 60 for us, but we know that the sum of angles in a triangle is 180. And if I see a 30 and I see a 90, then I know that this has to be 60, right? So now I know that I'm dealing with a 30, 60, 90 triangle. Now I know that across my 90 degrees is 2 times whatever's across my 30 degrees. So if they call this Z, then I know that 10 is equal to 2Z. And then if I divide both sides by 2, then I can just figure out that Z is 5. And then lastly, if they ask me for this side, then across 60 degrees is going to be whatever is Z times radical 3. So this is going to be 5 radical 3. So these ratios you absolutely have to memorize. So I'm going to put a big star here. And this is an example of how we apply those ratios in a question. And then the other one that you guys mentioned is the 45, 45, 90. So does anybody know those ratios? So if you think like common sense, right? If these two angles are equal, then these two sides must be equal. So this has to be an isosceles triangle. So automatically we know that this and this is equal. So we can call them both x. And then the relationship of the hypotenuse to x is something you guys just have to memorize. It's x radical 2. So again, we can do a question to practice. They can say, what is side C? And they can give you this example. So how would you guys solve this? What is side C? Good, right? This one's easy. It's just going to be 13. And if they ask for this one would also be 13. So sometimes they'll ask you these as standalone questions, but sometimes you won't know that you have to use this. So if you think back to that hexagon question that we did, and I'll redraw it for us, right? If we have a hexagon, and they tell us that this is a regular polygon, and then remind me again, what is the formula that we use to find one angle of a regular polygon? Yeah, good, right? So let's say we go through that whole process, right? We do 6 minus 2 times 180 divided by 6, and we figure out that one angle is 120. So what can they do with this, right? So let's say I just figured out that this is 120 and this is 120 and this is 120. So what they can do is they can cut this in half. And then they can do this and make this a right angle. And they tell you that this line is bisecting the hexagon. So if it's bisecting the hexagon, that means it's also bisecting this angle. And that means this has to be 60. And if we know that this is 90, that means this angle that's formed here is 30. So now you can see that from the regular polygon, now they might be testing us on something 30, 60, 90. And they might make us figure out what this side is or what this side is. Does that make sense? So over here, what X stands for is just a placeholder for whatever value that is. It's just for you to understand the relationship between this is. Like if this is 10, this has to be 20, and this has to be 20 radical 3. So in every triangle, the X is going to change. It's just for you to understand that whatever is across 30 is half of whatever is across 90. And whatever is across 60 is whatever is across 30 times radical 3. But that's very hard to like say without using this placeholder variable, or X in this case, for you to understand those relationships. All right. Okay, so that was a big crash course on a lot of geometry things that we just reviewed. Does anybody have questions on everything that we just covered? Can I go to the second page? This one? Okay. So just to finish up the geometry sort of talk, there's a few more things that I want to talk about. I want to talk about formulas for solids. So when they ask us about volume, this is less likely to come up, but I've seen it come up before too. And I'll go back to all these notes that you guys are asking for. But again, you guys will receive a PDF of this. So don't worry too much about having to copy everything. Okay, so let's talk about formulas for solids, like formulas for volume. Okay, so if you have a rectangular solid, so if you have something like a rectangular prism, what is the formula for the volume? Yeah, good. Length times width times height. You just multiply everything. Okay, what if you have a cylinder? Yeah, pi r squared h. Good. So the way that I always think about it, because I don't like memorizing things that, because there's so many things that you just have to memorize. That's the way math works sometimes, but some things you can logically figure out. So when we think about volume, right, basically each of our shapes has a base, which I'm coloring, right, for you guys. So when we think about it, if we have a rectangular solid, you just need to find the area of that base, and then you need to multiply it by the height, how many times you're going across, right? And it's the same thing for a cylinder. You find the area of your base of your circle, and then you multiply it by the height. If you imagine if you have a cylinder, like I have a cup here, which you guys, it's blending into the background, but imagine if you have a cylinder like a cup, and you find the area of the circle on the bottom, and you cut out a little paper of the circle, and then you have to stack those papers until you reach the top. So that's the way that you guys should think about volume. You should just get the area of the base. So in this case, here's our area, right? Pi r squared, and then you multiply it by the height. Or here's our area, length times width, and then you multiply it by the height. Okay, so how about the volume of a sphere? I don't know how to draw that. Who knows the volume of a sphere? Yeah, 4/3 pi something. Good, it's 4/3 pi r cubed. And then they ask this less commonly, but do you guys know the surface area volumes just for our notes to be complete? So let's do surface area of each one of these. Yeah, good. So for a rectangle, you flip-flop, right? So it's 2 times length times width plus 2 times length times height plus 2 times width times height. Good. How about for a cylinder? Good. So for a cylinder, it's 2 pi RH plus 2 pi r squared. And then finally for a sphere, it's 4 pi r squared. So these are the formulas that I would say that are most likely to come up on the test in terms of 3D kind of shapes. And then just some last final definitions to make the notes complete for geometry is you guys should know that what are these kinds of angles called? If I just have 2 lines that cross over, these angles in red and these angles in purple, what are those called? Yeah, so these are vertical angles. By definition, all vertical angles are congruent. So whenever you see 2 lines intersecting like this, you know that those opposing angles are congruent. So all vertical angles are congruent. So in this case, angle 1 and 2 and 3 and 4. So angle 1 is equal to angle 2, angle 3 is equal to angle 4. What can you guys tell me about angles 1 and 3? Yeah, so then you need to know that all straight angles are supplementary. So I want you guys to get used to this vocabulary. So if you ever tell you supplementary, by definition, that means that they add up to 180 degrees. So in this case, angle 1 plus angle 3 is equal to 180 degrees. Angle 3 plus angle 2 is equal to 180 degrees. Angle 2 plus angle 4 is equal to 180 degrees. And angle 4 plus angle 1 are equal to 180 degrees. And all of those angles are supplementary. What does it mean? What does complementary mean? Yeah, if they tell you 2 angles are complementary, that means that those add up to 90 degrees. Okay, good. And then you guys should know about parallel lines cut by a transversal. So what does that mean? So if you have 2 parallel lines and they're cut like this, there's a relationship between the angles, right? So first, let's label everything. 1, 2, 3, 4, 5, 6, 7, 8. So already based on what we learned, you guys, what can you tell me about 1 and 4? Yeah, right. So let's list all the vertical angles here. Okay, right? So all of those are vertical, we can agree. And then I'm not going to repeat the notes, but there's a bunch of angles also here that are supplementary, right? So you know that 1 and 3 are supplementary, 1 and 2, 2 and 4, 4 and 3, 5 and 6, 6 and 8, 8 and 7, 5 and 7, right? Okay, so now there's another relationship called alternate interior and alternate exterior, and those are also congruent. So how do we do that? So the way that I think about it is when we think about, so I want you to think about alternate interior and then alternate exterior. So interior, I want you guys to think that you're inside the two parallel lines, right? So I'm going to highlight there are spaces inside, right? So I'm going to highlight in purple. So here's our inside, right? So that means we're only picking between angles 3, 4, 5, and 6. And alternate means that they're on opposite side of the transversal. So in this case, angles, and I'm going to circle them, angles 3 and angle 6 our alternate interior. So angle 3 is equal to angle 6 by alternate interior. And then similarly, angle 4 and angle 5. So angle 4 is equal to angle 5. And then the same rule applies for alternate exterior, but we're on the outside, right? So now I'm going to highlight on the outside of the parallel line. So you're picking between this and this. And again, you're going to be on opposite sides of the transversal. So for example, let's see what color I can use. So angle 1 and angle 8 are alternate exterior, and then angle 2 and angle 7. Okay. All right, so does anybody have questions on anything that we covered in terms of all the geometry? Sure, here's the page with the volumes. So after these notes, I want to now review like commonly used fractions on this test, fraction to decimal equivalents that I recommend that you guys memorize so you don't waste time converting. And commonly used squares. So I teach all my students to know up until 25 squared. You should have those memorized also. So I just want to give you a page of lines where you have all of that. Let me see if there's anything else I want to cover. The last thing with geometry, just again, for the notes to be complete, is just formulas for quadrilaterals. So obviously for the perimeter of any quadrilateral, you just add up the sides. So I don't need to put that into our notes. But what you guys should know is in a square, all sides are equal, right? And the area of a square is just side squared, and the perimeter is 4 times the side. And sometimes they also ask you guys about the diagonal. So with the diagonal, you can memorize it, right? So I can tell you guys that the diagonal of any square is going to be radical to A, where A is the area. But you can also always solve for it because you know that this is 45 degrees and diagonal, you're cutting this in half. So it's actually just going to be side radical 2. So there's 2 formulas for the diagonal of a square. And then if we talk about rectangles, you should know that the area is length times width. The perimeter is 2 length plus 2 width. And you should know that the 4 angles of any quadrilateral will always add up to what? 360 degrees. And then if we do parallelograms really quick, the area here is base times height. What is the area for a trapezoid? Yeah, so it's 1/2 base 1 plus base 2 times height. That's the area of a trapezoid. So this is kind of like the majority of all the geometry formulas that you guys should know. I like doing this in our webinar because I want you guys to create a little notes for yourself, like a cheat sheet that you can look at the morning of or the day before the test, not heavy studying, but just glancing over as review of all the things that should already be in your head, but in a nice organized sheet. Okay, so let's move on. Switch gears a little bit before we get to practice to commonly used percent, decimal, and fraction equivalents. So this is not something that you 1000% need to memorize. It's just if you have these memorized or if you're familiar with them, your life on this test becomes easier because you don't need to spend time doing the arithmetic. So for example, if they give you 1/6, right? And you get 1/6 as an answer, but you notice that all the answer choices are in terms of a decimal or in terms of a percent. You can sit there and say, okay, well, 1 divided by 6 is 0, and that goes in 1 time, and then that's going to go in 6 times, and that's going to go in 6 times, and see that whatever it is, right? But I don't want you guys to spend time doing that kind of arithmetic. So if you know that 16/1/6 is equal to 0.167, or approximately 16 2/3%, or 16.7%, right? So that makes your life easier. And you don't have to do this to every single fraction, but there's just some common ones that I recommend that you know. They come up a lot on the SHSAT in my experience of many years teaching this exam. And the more practice that you do, a lot of these things you guys already probably have memorized just because you've seen them so many times. But I just want to teach you how to actually have these tools in your toolbox and like extract them. So don't be afraid if you see 1/6 to just pick 16.7% or just pick 0.167. You don't need to spend time doing that division and checking your work. You can annotate the question and you can put a little dot next to it, meaning that if I have extra time, I can go back and I can check that division 1 divided by 6 to just, triple 100% check for myself. But on your first run through the test, this isn't something that should be taking up time. These conversions should be automatic. So that's 1/6. Another common one that you should 100% know is 1/3. So that is 0.333 or 33.3%, or 33 1/3%, or 33.3%. 2/3, if you have 1/3 memorized, then 2/3 is really easy for you to memorize. That's just 0.667 or 66 2/3%, or 66.7%. Okay, which other ones are important? The fifths are important. So 1/5 is 0.2 or 20%. And then all the fifths you should know, right? But I don't have to write all of them down, but you can say 2/5 should be 40.40 or 40%. And then 3/5 is 0.60 or 60%. And then 4/5 is 0.80 or 80%. And again, you don't have to memorize all of them. Does that make sense? You don't have to spend that time to memorize all of them, because once you know that 0.2 or 1/5 is 20%, you know the other ones almost automatically. Another one that comes up commonly that I want you guys to know is the other 6. So we did 1/6, but you should also know 5/6. So 5/6 is 0.833 or 88 1/3%, or 83.3%, right? Those are all equivalent. And then the other ones I see commonly that come up are the eighths. So 1/8, is going to be 0.125 or 12.5%. And then 3/8 is going to be 0.375 or 37.5%, and 5/8 and 7/8, and that's it. So 5/8 is 0.625 or 62.5%, and then 7/8 is 0.875 or 87.5%. Now, can I guarantee that they're never going to ask you anything else? No, I can't. But can I guarantee that approximately 80 to 90% will be something that we've covered in this realm? I can. These are the most common ones that I've seen. The other ones that I'm not even spending time on is like 1/10, because I think most of you guys know this. 1/10 is just 0.1 or 10%. And then you guys want 1/9? We can do 1/9. 1/9 is always going to be repeating. So 1/9 is 0.111 repeating. This is 0.1666 really repeating, but I just rounded up. But those little specifics are not so important on the test. So this will be 11.1%. And then, yeah, 2/9 is going to be 0.222 repeating, 3/9 is going to be 0.333 repeating, and so on and so forth, right? So we don't need to write all those down. Same thing with like 3/10, 4/10, 5/10, 6/10, etc. So this is a good list. If you guys have this memorized, I promise you that a lot of the questions will go a lot faster because they really stick to all of these. And then notice like there's some repetitive ones, right? So I didn't do 2/6 because that's the same thing as 1/3. Or I didn't do 4/8 because it's the same thing as 1/2. And I didn't write 1/2 down because I assume that you guys should all know that, but you should definitely know 1/2 as well. So 1/2 is 0.50 or 50%. So this is a good list that I would recommend that you guys memorize, review, and a lot of this is going to come naturally because you've been exposed to all of these and questions so many times. So you don't even have to put in so much effort to memorize it. Just looking it over one time at night for a few days, these next 2 days, 3 days, you'll have it memorized by the end of the week.
And I just want to add, you guys can take screenshots right now and just like save it on your phone. So those of you, or just take a picture just so that you like keep memorizing these. Okay. And writing them over and over again will be very helpful. Rewriting this for 1 hour straight, just over and over again, you're going to memorize this in 60 minutes.
All right, so I'll leave it up for a second for anybody that needs to take screenshots, and then we'll do the same thing with commonly used squares. So I want you guys to know all the squares from 1 all the way up to 25. Those are the most common ones that are going to come up on this test. And again, you saw how they're used in Pythagorean theorem. The goal is that you guys all know how to multiply like 24 by 24. I'm certain of it, right? But that's not what this test is testing you on. And that's not knowing how to multiply 24 by 24 isn't going to get you that high score. But not saving yourself the time to know 24 by 24 and doing that automatically, and saving any chance for making a sort of like arithmetic error when you're doing a big subtraction or a big multiplication. And you're also saving yourself time so you get to the right answer faster, and you can save the time for a section that you're weak on. Let's say it's reading comprehension or grammar, or you can save the time for a math word problem that's more complicated and you need more time to figure it out. It's a logical reasoning type problem. So I want you guys to save as much time as possible on this easy arithmetic stuff, okay? So let's do squares. Let's use commonly used squares. So I want you guys to do this with me, right? Because extracting this from your memory right now, even if you don't have them all memorized, is going to help you remember them. So I'm going to write them all out and you guys start putting them in the chat. So 2 squared, 3 squared, we're starting with the really easy ones, but we're going to go all the way up to 25. Okay, let's see. Let's see who's up to what. Okay, good. You guys know up to 12. What about after that? Who knows up to 20 at least? Okay, let's start filling this in. Good, good, good. You guys are really blowing up the chat. All right, let's put this up on the board so everybody can see. So 2 squared, that one's easy, right? That's just 4. Then we have 9, then we have 16, we have 25, 36, 49. We have 64, 81, 100. So this is absolutely like, I think most of you guys know up till here. So 11 to 20 is like next level. If you guys know this, then you're in an excellent place. 1 to 10 is like, everybody should know this. That's basic. So 11 to 20. So we have 121. Then we have 144, 169, 196, 225, 256, 289, 324, 361, and then 400. So if you know up to 20, you're really in a really excellent space. These next 5 are like, if you want to be really extra, really certain. So 21 squared is good. Somebody's putting it in the chat, 441, good. 22 squared is 484. 23 squared is going to be 529. 24 squared is going to be 576. And finally, the last one is 625. So again, if you write this a few times, you memorize it, very easy, and it's going to make your life a lot easier. And again, we saw that the way that this is used. So have a high suspicion of needing to use this whenever you see a right triangle and whenever you have to use Pythagorean theorem. So I want to sort of get your brain moving in terms of like, I'm giving you all the toolbox, right? I'm filling your toolkit, but I also want you guys to be good at knowing when to take out which tool, right? Like knowing what the test makers, what the question wants of you. So I want to direct your brain to, if you see a right triangle and you have to use Pythagorean theorem, you should also connect that to what are the commonly used squares that I know, and what are the Pythagorean triplets that we just reviewed earlier, and how are they related to these squares? Because most of the triplets that they'll use are going to be somewhere here, right? So 3, 4, 5, that one's an easy one. But what are the other triplets that we learned that are showing up in these commonly used squares? Right? We learned 7, 24, 25. Right? So here's 24, 25, and 7. So if you know 24 squared, you don't have to spend your time doing that because you know 24 squared is 576. Or automatically, you don't even need to do Pythagorean theorem because you recognize 7, 24, 25 as a triplet. Does that make sense to everybody? So there's like layers of how much faster and how much more efficient you can get at solving these math problems.
Everyone, I just want to remind you, this is Frances Kweller. I just want to remind you, you can take a screenshot, you can memorize, you can look at all of this, just keep practicing these questions. I also want to remind you, those of you who are testing on Wednesday, so Tuesday, I understand there's no school, which is amazing, good fortune. Monday, take it easy. If you're able to pick your children up early on Monday, that would be ideal. Keep it super calm so that you have a very restful Saturday, Sunday, Monday, and Tuesday. You can always go into school Monday to clock in for the attendance, but if you can leave early, please do. It's a good day to just begin your rest and relax and light review. Keep it super mellow the days leading to the test. Okay, everyone? I also want to remind you, next week, Olga's running the stress reduction webinar. It's super helpful, written with love by yours truly. And we also have the webinar by Emily Marion, which is on the lottery. That webinar will be for parents, the stress reduction, both parents and kids. And Miss Kweller, I need to remember all these reduction techniques. So please remember, next Monday, Tuesday, and tomorrow, Olga has the grammar tools, tips. It's also called the verbal reasoning section. So just remember, that's tomorrow's webinar. So I'm happy that you're participating. And just remember, tomorrow, and then again Monday, Tuesday, we will be busy in the days leading ahead. Those of you who are testing after November 8, you're welcome to email us. Maybe we'll do an extra 1 or 2 webinars because there are going to be quite a few of you testing later. We are happy to host more so that you feel, supported until the test. All right, I'm going to go back on mute. Olga, just you can proceed if you guys have any questions. I also want to remind you, we emailed the recording from yesterday so you can listen and re-listen. We're going to keep the recordings up for a few days so that you have the option to listen to them. All right, I'm going back on mute.
Okay, so commonly used squares, and then I'm not going to write all this out, but you guys should also understand this goes both ways, right? So when we say squares, you should also know about square roots, right? So if you know that 2 squared is 4, you also know that square root of 4 is 2, right? So it goes both ways is what I'm saying. So same thing, if you know 20 squared is 400, if they ask you square root of 400, you also know that's 20, okay? All right, so we're about at that halfway point. There is a lot more that we can review, but I want to make sure that we actually look at real questions from the exam and go through those questions together. And I teach you how all of these things that we just covered apply to that. And we also do more strategies as we look through the actual questions, right? So as we're at our halfway point, everybody can take a nice deep breath. If you need to stand up for a second and stretch, that's going to be like your 30-second break. And then we're going to go to the actual questions from the exam. And again, this is Form A from the 23-24 release DOE exam. So everybody take those 30 seconds to relax, to take a deep breath, to stretch, and then let's keep going through these actual questions and work through these together. Okay, so let's get started. So we have Miss Lee opened a retirement account and she deposited $2,500. This account earns 4% simple interest annually. How many years will it take her to earn $500 on her $2,500 deposit? Okay, so the really big key here is they tell you simple interest. So there's going to be the same way that I teach you guys in reading comprehension. Sometimes math is a reading comprehension test also because they give you word problems, which have words, which means that you have to read and understand them. So simple interest is our key word here. So you guys should know that simple interest, there's a formula for it. So simple interest, we're going to call this Y, is equal to P times R times T. So let's define all of these variables. So Y is simple interest. P is your initial deposit. And R is rate or interest rate. And then T is time. And because the interest is annually, that means time is in years. So that's another important point that sometimes students mess up. So because they tell you that it's annually, you know that the unit for time is in years. And for this formula, usually the unit of time is in years. So now that we know the formula, we know all the pieces, we can just plug in. So they tell us that they want her to earn $500, right? So that means that this is the simple interest. So $500 has to equal her initial deposit, which is $2,500, the rate, which is 4%, but we can't put percent into a formula, so we convert this into a decimal, so that's going to be 0.04, and the time, which is what we are solving for. And now we just have a simple equation that we need to solve. So 2,500 times 0.04. So this is a place for a strategy, right? So how do I do this quickly? So am I going to say 2,500 times 0.04 and do this crazy multiplication? No, this is not the space to do that. This is a space to say, okay, well, 0.04 is 4 out of 100 times 2,500 over 1. And look what happens. The zeros can just disappear. So now we can easily say, well, 500 is equal to 100 times t. And then I need to solve for t. The t is attached to the 100 by multiplication. So in order to solve for t, to isolate t, I have to get t alone. So I'm going to do the opposite operation to isolate t. So I'm going to divide both sides by 100. And we have our answer, which is that t is equal to 5 years. And again, whenever I get to my answer, I always just double check the question and they say how many years. So I make sure that I have the right answer, because they could have asked how many months. And then you'd have to do the extra step of multiplying 5 years times 12 months in each year and getting the answer of 60. Okay, so from this question, let's reflect on some of the strategies that I just went over. So number one strategy is to simplify, right? So do not do big operations of arithmetic. So instead, simplify. And then number two is always reread the question after you got your answer to make sure you answered the question. Okay. Next one is asking us for the value of this expression. Okay, so what do we see in this expression? What is this called that I'm highlighting? Yeah, good. This is absolute value. And what do you guys know about order of operations? So what would I do first here? Yeah, so parentheses and also like this exponent needs to be taken care of. So you guys all said PEMDAS. So there's no operation in parentheses. So the next one is exponent. So that's what we need to take care of. So we're going to have 6 minus 9 divided by absolute value of -3. What's -2 cubed? Good. So it's going to be minus or plus -8 times 1 1/2. Okay, so the next thing that I would take care of is the absolute value. So then we're going to have 6 minus 9 divided by 3 minus 8 times 1 1/2. The next thing is going to be multiplication and division. So that means I do this and I do this. So we're going to have 6 minus 3. And then 8 times 1 1/2 is going to be 12. So 6 minus 3 minus 12. And then we just do the leftover subtraction from left to right. So 6 minus 3 is -3 minus 12. And then -3 minus 12 gives us the final answer. Oh, sorry, this should be +3 minus 12 gives us the final answer of -9. Okay, does anybody have any questions with this one? Okay, next. So this one is just to solve for x. So in this case, we're using all the same rules that we went over above. So you still use order of operations, but this is an extra step because it's not just arithmetic, but we also have to solve for x, right? So we're using PEMDAS, but then we also have to solve. So the first thing that we're going to do is we're going to distribute. When you distribute, you have to be really careful because this is a negative. So when you distribute the 2, you have to make sure that you're also distributing the negative. So this distributes to both of these terms. So that's the most common mistake that can happen here. People distribute the 2, but they forget that it's negative, and then all your signs get flipped. So make sure that when you're distributing, if you're distributing a negative, the negative gets distributed. So we have 7x plus 3 minus what's negative 2 times 2x? Good, 4x. And then negative 2 times 1 minus 2 is equal to 13. And now the next step is to combine the like terms. So I'm going to underline my like terms. And then we're going to combine them. So what's 7x and negative 4x? Good, 3x. And then 3 minus 2 is plus 1, gives us 13. Can subtract. So 3x is equal to 12. And then we divide and we get our answer. X is equal to 4. And again, you always go back to the question, make sure they wanted X, and they did, because they could say, what's 2X, what's 3X, what's 5X, and then you would get the answer wrong for a silly reason. And in this case, they do want X, and X here is 4. All right, so we got through the first 3 grid-in questions. Just as a review of how to grid in, be very careful when you grid in. Don't forget things like negative signs. Don't forget decimal places. You can't stack grid in. So don't grid in 0 and 2 here at the same time. That will be automatically wrong. So make sure that you follow the directions of how to grid in, and make sure that you practice gridding in. So when you guys take full-length practice tests at home, make sure that you print out a sheet like this and you actually practice gridding, because that will take time also, and there's a proper way to do that, and you don't want to lose points for something silly like this. Okay, the last 2. And then we'll move on to the multiple choice. Okay, so they tell us L is perpendicular to N, and that's why they put this 90-degree angle here. And they're telling us what is the value of X. So this is what we have to figure out, what X is. Okay, so what can you guys tell me? Where would you go from here? What do you see? What are these? And these? Good, so these are vertical angles. So how we reviewed is that vertical angles are congruent, right? So I know that this is 90, and by definition, this has to be 35. And then we reviewed that the sum of angles in a triangle that I'm highlighting here is 180. So we know that 90 plus 35 plus X has to equal to 180. And then it's just the matter of simplifying it, right? So 125 plus X is equal to 180. We subtract both sides from 125. And we get our answer, which is that X is 55 degrees. Good. Okay, now they're telling us the mean value of 8 numbers is 17. So what does mean? What does mean? Yeah, good, average. What is the formula for average? Yeah, it's the sum of numbers, and then we divide by the number of numbers, right? So in this case, I don't know what those numbers are, right? But I know that there's 8 of them. So I can say, well, x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 plus x8, right? There's these 8 numbers, and I know that when I add them all up and I divide them by 8, right? Because there's 8 of them, I get an average of 17. Does that make sense to everybody, the way that we set this up? So what can I do from here? How can I get the sum of those 8 numbers? Yeah, good. So to get the sum, we multiply 8 by 17. Okay, so what's 8 by 17? What is the sum of these numbers? Should be 136. So we know that the sum of x1 plus all the way to x8 is going to be 136. Now, I want you guys, just as a side over here, as a strategy, whenever you're picking an answer, right? So I know that I have to multiply 17 by 8. I don't know what this is off the top of my head, right? I'm not that good, but I know what 8 times 7 is. 8 times 7 is 56. So I know that I'm going to put a 6 here. I'm going to put a 5 here. Doesn't matter what else, but I know that my answer has to end with a 6, right? So I saw somebody in the chat put in 119. So automatically you would know that that's wrong. And I use this all the time when I'm also picking answer choices, right? Like let's say my answer was 136 and my options were 119, 141, 175, and 136. Automatically, I don't even have to finish multiplying. I know that my digit is going to end in 6. My units digit is going to be 6. So I don't need to spend time doing all this arithmetic. I know that this is automatically my answer. Is that clear? So this is another strategy of estimation that you can use to quickly get to your answer and take advantage of the fact that this is multiple choice. So we haven't been able to do that yet, because we've been doing the not multiple choice questions, but I just want to mention this here as well, and I'll show you how we use it in the actual multiple choice as well. Okay, just shifting gears back to this question. I multiplied 8 by 17 to get what this sum is, right? So it's kind of like if I multiply this by 8, this 8 goes away, and if I multiply this by 8, I get what the sum is of the 8 digits. And I figured out that my sum is 136. Then they tell us that these 3 numbers are discarded. So I know that my sum is 136, and then I'm getting rid of 9, 11, and 20. Let's say this was 9, 11, and 20. I'm getting rid of it. So that means that my sum is going to decrease by 9 plus 11 plus 20. So my new sum is going to be 136 minus 9 minus 11 minus 20. So I'm subtracting 40, so I'm going to be left with 96. Good. And now, how do I find the mean of the remaining numbers? Well, again, we go back to our formula. So our average is going to be sum divided by 5, right? Because now I have 5 numbers, and now here is my new sum. So my answer is going to be 96 divided by 5. And automatically I can see that 96 is not divisible by 5, right? It doesn't end in a 5. So it's going to be a little bit annoying, right? But then we just need to do this division. 96 divided by 5 goes in. So it's not 19 and 1/5, and we learned that 1/5 is the same thing as 0.2, so 19.2. Okay. So the big takeaway with this question is I want you guys to think systematically, right? So takeaways. So think systematically. So if you see simple interest, if you see average, these are key words communicating to you to use the formulas associated. So as soon as you see these, you should write down the formula. Does that make sense? Sure, I can go back to the first page. All right, guys, so we got through all of these questions. Let's move on to the multiple choice. Okay, so we got to the multiple choice. So now we have 3 to the 4th power plus 7 to the 4th power. So how do we do this? So one thing that you guys should do, what I would start with, is 3 to the 4th power, right? Because that's a smaller number. So the way that I usually like doing this is understanding that 3 to the 4th power is just 3 times 3 times 3 times 3. And then we can easily say this is 9 times 9, this is 81. Right away from here, you can get rid of this, right? Because it's already going to be greater than 40. So I would automatically cross that out. And then we're going to add it to 7 times 7 times 7 times 7. So this is going to be 49 times 49. Now, 49 times 49 is going to take me a very long time to do. Not a very long time, but it's a substantial multiplication. What's going to be easier for me is to do 50 times 50, right? Because I know 5 times 5 is 25, and then I can add the 2 zeros. And I know that my answer is going to be a little bit less than 2,500, and then I'm going to add this. So I know that I'm going to be in the range of the thousands. So right away, I'm comfortable with picking C as an answer. Does that make sense? So what I want you guys to do is work through this quickly. I know that you guys could sit there and do, okay, well, 49 times 49, 81, you're going to carry the 8, 4 times 9 is 36, plus 8. This is going to take too much time. So you must use estimation as your strategy. And what I would do is I would make a little annotation for myself. So I'd put a little dot, and this dot to me would communicate, okay, when I'm done with the test, if I have a lot of extra time, I can go back and I can multiply 49 by 49 and prove to myself that that's the absolute correct answer. I can prove it to myself. But on my first go through the test, I don't want to waste time on this because there's going to be a question that actually needs my time. But looking at this, I'm like 99% sure that that's the answer. Does that make sense? Good. Somebody else brought up another point. So we can see that this 49 times 49 is going to end in 1. And then we're going to add 81 to whatever ends in 1. So we know that it's supposed to end with 2. So that's another way that you can confirm to yourself very quickly that that's 99.9% the right answer. And you don't need to spend your time actually doing that arithmetic. So these are the types of strategies that we employ for multiple choice. We do estimation. We use the units digit to get to the right answer. Okay, moving on to the next one. We have in 1 week, 1 3/4 inches of rain fell on Monday, 2 2/3 fell on Tuesday, and 7/8 fell on Wednesday. So all they want is for us to add. So this is a nice, simple question. Our only problem is that everything's in a different denominator. So we just have to use common denominator. So it's going to be 1 3/4 plus 2 2/3 plus 7/8. So again, thinking logically, automatically, I'm comfortable with getting rid of this and this because 1 plus 2 is already 3. And then I know that these are going to be much greater than 1. Like it's not going to be 4/5. It's not going to be 1/2. 3/4 is already greater than 1/2. And 3/4 plus 2/3 plus 7/8 is definitely going to be greater than 1. So I already know that none of these is my answer. And now I don't even have to think about the common denominator because I can see that both of the possible answers are in terms of 24. So that's what I'm going to do. I'm going to change everything in terms of 24. So how do I get 4 to look like 24? Well, I have to multiply by 6. And if I multiply this by 6, I have to do the same thing to my top, right? That's the rule. Because if I'm multiplying by 6 over 6, I'm not changing the value because 6 over 6 is just 1. Same thing here. How do I make 3 look like 24? Well, I have to multiply it by 8. And whatever I do to the bottom, I'm going to do to the top. And then the last one, how do I make 8 look like 24? I have to multiply it by 3. And same thing, whatever I do to the bottom, I have to do to the top. So now we have 1 1/18 over 24 plus 2 1/16 over 24 plus 21 over 24. And now I have to do all of that math. So now I have to do, okay, well, 18 plus 16 plus 21. So who can do that for me? 18 plus 16 plus 21. So I have 1 plus 2 is going to give me 3. And then I'm going to have 55 over 24. So 24, I can right away take away 48 out of 24. So I can say 3 48 out of 24 plus 55 minus 48 is going to give me 7 out of 24. So then 3 plus 2 plus 7 out of 24, that's 5 and 7 out of 24. And again, at this point, you can kind of stop because you can see that it's definitely going to be greater than 1 out of 24, right? Like I don't have to actually see that 48 and 55, the difference is 7. I can already see that it's definitely not 1, right? It's not like it's 49 out of 24. So at that point, I can automatically pick E and move on. Okay, moving on to 65. We have Jamel, who works at a computer store. He's paid an hourly rate plus 15% commission. Last week, he was paid $802.50 after he worked 30 hours and sold $12.50 worth of computer products, and they want us to figure out his hourly rate. Okay, so first I would figure out how much he got from commission. So commission means that he gets 15% on everything that he sold. So that means that he got 15% of $1,250 because that's how much he sold. So this is his commission. So in math, whenever you guys see the word of, this tells you multiply. And in math, whenever you have percents, you don't actually work with percents in your equations or in your arithmetic. You always have to convert it to a decimal. And you guys know that percents literally mean percent. And I think it's in Latin, it means out of 100. So 15 out of 100 is 0.15, sorry. So this we can transform to 15 out of 100. Or 0.15, of means multiply, and we multiply it by 1,250. Like we learned before, we can simplify, right? So the zeros can go away, but then we can do a little bit better than that. So not only can the zeros go away, but we can also divide by 5. So 10 divided by 5 is easy, that's just 2. And then 125 divided by 5 is 25. So now we have 25 times 15 over 2. So 25 times 15 gives me 375 and then over 2. So that means that he made $187.50 just from the commission. But he was paid this in total. So now I want to see, well, if I take away the commission, how much did he get per hour, right? So now we take his total, 802.50, and then we subtract 187.50. So we get $615. So this is his base salary with no commission. And now they want to know what is his hourly rate. So this is how much he made and how much did he work? 30 hours. So we need to divide this by 30 hours to get his hourly rate. So automatically looking at the answer options here, I know that these are too big, right? Because 30 times 30 is 900. And this is even bigger than 30. So that's too much. So I know that this should be somewhere close to 20 because 30 times 20 is 600. So I'm pretty comfortable picking this. And this one is also still too high. But you can do the actual math and divide it and you'd get 20.5. So again, because this is so heavy on arithmetic, see, there's nothing that you can do here to make yourself get to the answer faster, right? You have to take the time to actually multiply these, to divide this, to subtract this, but wherever you could save the time is where you could save the time, right? So that's why I tell you guys that you can save these 30 seconds here, and you can save those 15 seconds here, and even here at the very end, you can save those like 15 seconds, and all those seconds are going to add up, and ultimately you're going to save yourself minutes and minutes and minutes, and you'll be able to get through the exam faster and save time for questions that you're really not sure on how to do instead of spending time on arithmetic. Okay. Does anybody have questions? Okay, let's keep going. So we have a revolving sign makes one complete revolution every 90 minutes. If the sign starts moving at 2:30 p.m., at what time will the sign complete 8 revolutions? Okay, so what do we need to figure out here? So basically, we have to figure out how many minutes it's going to take for the sign to make those 8 revolutions. So 1 revolution is 90 minutes. And they're asking us about 8 revolutions. So that's going to be X minutes. So you can see the relationship here is to go from 1 to 8 is times 8. So we're going to do the same thing here, times 8. So our answer is 720 minutes. Now, because it's going to be very annoying to sit there and count minutes and say 2:30 p.m., 2:31 p.m., 2:32 p.m., 720 times, we can convert this to hours. So now we know that in 1 hour, there are 60 minutes, And now we want to know, well, how many minutes are in 700, how many hours, sorry, are in 720 minutes? And again, what's the relationship between 60 and 120? I mean, 720, sorry. Yeah, times 12. So we'll do the same thing here, times 12. So we know that it's 12 hours. So what's 12 hours after 2:30 p.m.? It's going to be 2:30 a.m. Okay. Then they tell us we have a number line. Points Y and Z are not shown on the number line above. They're telling us that X is the midpoint of WY. So I guess that implies that Y must be here. And then Y is the midpoint of WZ. So that implies that this should be Z. And then the question is, where should Z be located? So we just figured that out just as we were reading it. So that's D. For people that are confused, when they tell you the midpoint, it means it's in the middle, right? So if X is the midpoint of WY, all I did was, okay, well, from X to W is 2 units. So that means there has to be 2 units to X to Y. And then same thing, if Y is the midpoint of WZ, well, here there is 1, 2, 3, 4 units. So I'm going to go 4 units to get to Z. This one, which makes the equation above true? Again, what you can always do with proportions is you can absolutely always cross multiply. So you can 100% here say 81 times n is equal to 90 times 10, and then you can divide by 81. You can absolutely do that. Or you can think, okay, well, you want to look for relationships either this way or this way. And then you want to repeat those relationships. So the relationship that I see that's easy here is to get to 9 to 81, I multiply by 9, right? So to get the opposite way from 10 to n, I'm going to divide by 9. So I know that the answer here is 10 over 9, which is the same thing as 1 and 1/9, which is choice F. So I think that would be a little bit faster than doing this in this case. But even in this case, you'd get 90 over 81, and then you divide both sides by 9 and still get 10 over 9. Okay, then they tell us n is an integer. Okay, so what does integer mean to you guys? Does integer include negative numbers? Does it include fractions? Yeah, so integers include negatives, right? So it can be a negative number, it includes 0, and it can be any positive number, but they have to be whole, right? So it doesn't include any fractions or decimals. But that's important because I now know that it can be negative or it can be 0. So n is an integer, and then they tell me that 3n plus 3 is an even number. And then they say which expression must also represent an even number. So a lot of times what I do for these kinds of questions is I plug in. And what's important to realize here is what to plug in, right? So because n is an integer, I would try a negative number, I would try 0, and I would try a positive number. And I would see which one of the following has to be true, right? So let's say we try a negative number. Let's say we try negative 3, right? Let's say n is negative 3. Then we say, okay, well, 3 times negative 3 plus 3. That's negative 9 plus 3. That's negative 6. That's an even number. So n could be negative 3. So now I'm going to plug in negative 3 into each one of these and see which ones I could cross out. So negative 3 plus 2 is going to give me negative 1. That's not even. That's gone. 2 times negative 3 plus 3, negative 6 plus 3 is negative 3. That's not even. I can cross that out. So are you guys following so far? Next one, 4 times -3 plus 5, -12 plus 5, that's -7. That's not even, I can get rid of that. And then finally, the last one, just to make sure that this one works and we didn't mess everything up, 5 times -3 is -15, plus 1 is -14, that is even, and here we got to our number. So sometimes you have to do multiple cycles of plugging in, and sometimes on your first try, you can eliminate all the answers. But the important thing for you guys to take away from this question is, what is the definition of an integer and what are the possibilities of the numbers that you can plug in? So this would also work if you like plugged in +3, or if you plugged in +5, same thing. You would just plug in, let's say 5, right? Let's say n equals 5. You double check that this condition is true because the question is setting you a condition, right? So you'd say 3 times 5 plus 3, 15 plus 3, that's 18. Okay, I'm good, right? N can be 5 because 3n plus 3 is an even number. And then you would check all of these and then you would say, okay, 5 plus 2, that's 7. That's not even, cross it out. And then 2 times 5 plus 3, that's 13. That's not even, cross it out. 4 times 5 plus 5, 25, that's not even, cross it out. 5 times 5 plus 1, that's 26, that's even, still correct. Does that make sense? So I'm comfortable with you plugging in one time, and then again, you can just annotate this question with a little dot, and then when you go back to it, when you have extra time, you can plug in 3 other numbers or 4 other numbers just to 100% confirm to yourself that that's the correct answer. Okay, and we get to the last one on this page. So here they're telling us positive integers. So now we can no longer think of negative numbers. So they're telling us that the product of 2 positive integers is 65. So now I'm thinking, okay, what are the factors of 65, right? What are the different types of 2 numbers that multiply to 65? That's what I would be thinking. So what are the different pairs that can multiply to 65? Well, it's obviously divisible by 1, right? Is it divisible by 2? Nope, it's not even. Is it divisible by 3? How do I know if it's divisible by 3? The rule is the sum of digits, right? So 6 plus 5 is 11, and 11 is not divisible by 3, so I know that the whole thing is not divisible by 3. So it's not divisible by 3. Then I think, is it divisible by 4? Can't be because it's not even. Is it divisible by 5? Yes, because it ends in 5, right? So 5. So 5 and what? It's going to be 5 times 13. And 1 and what is going to be 1 and 65. So now I check these sums, right? So 5 plus 13 is 18, and 1 plus 65 is 66. So are any of those answers? 18 is right here. Okay. Do you guys have any questions, or is everybody good to keep going? All right, let's keep going. Oh, where did I get 13 from? So I know it's divisible by 5, so I'm looking for the other factor. And 65 divided by 5 is 13. I just did this part in my head. Okay. Now they're telling us if n is an odd integer that is less than negative 3.25. So be very careful when they're asking you less and greater. And we have a lot of words here, right? We have less, we have greatest, we have odd integers. So you have to think of a way of organizing all of this in your head. So usually I try to think of a number line. So when you think about a number line, and you think that, okay, so here, let's make this our 0. Let's say this is -1, -2, -3, -4. So -3.25 is going to be somewhere here where I'm marking in an X. And they want an integer that's less than that. So I know that I'm dealing with something here, right? Because left on a number line is always less. So I'm going in this direction. And they want us to know what is the greatest possible value of n. Okay, so I know that automatically it can't be any of these. because all of these are to the right of my X point. So automatically I know that the answer is -5. Does that make sense? Okay. All right, so now they're giving us a box plot. So these are also common questions, not necessarily a box plot, but they'll give you a bar graph or some sort of figure that you also have to interpret. So we have to be comfortable with interpreting these types of things. So the box plot is used to display the distribution of the ages of students who signed up for swim lessons. So what can we tell from this box plot? Well, we know that's this value here, 7, this is our minimum. And we know that this value, this here, this middle point is our median. And these two box plots, these are our first quartile and our third quartile. So this is just by definition of how a box plot works. That's why I'm labeling all of this for you guys. And then this here is our max, right? 12 is our max. So now we're going to go through all the options. So since the value of the third quartile is 10, what that means is that this is what that means. This is a fourth of the students are in this range from 10 to 12. A fourth of the students are in this range, and half of the students are in this range. That's what the quartiles mean. So this is 1/4 of the students are between 7 and 8, half of the students are between 8 and 10, and 1/4 of the students are between 10 and 12. So that's exactly what this says. Are at least 10 years old. So that means they're 10, 11, or 12, and that's this yellow highlighted. So an outlier is a value that's really, really different than all the other ones. So 7 through 12, those are all really, really close. So an outlier would be if the maximum or the minimum went like to 1 or like went to like 100. So an outlier is a number that is very far away from the rest of the set. And then if we look at choice F, exactly 9 years old, a box plot can't tell us. And again, this is similar to like on the reading test, stay away from things that are very extreme. Exactly is too extreme here. A box plot can't tell us or won't tell us that. We know that half the students are between ages 8 and 10, but not exactly 9 years old. And then the interquartile range is 3 greater. So the interquartile range we can calculate. That's going to be 10 minus 8, which is 2. And then 12 minus 7 is 5. And you can see that the interquartile range is less than, not greater. So that's how they're trying to trick you. So the difference between them is 3, but they're trying to trick you. How I got 1/4. So this is just the way that a box plot works. So if I draw you a box plot, right, like this, and you have a value here. So these quartiles are ranges. So whatever value is here, this is the first quartile. So you divide the data into fourths. So what you're telling people is that a fourth of the data lies here. And then this is the third quartile. So this is the third and fourth. So a fourth of the data. So the lower half of the lower fourth is on your left. So this is a fourth of the data. And then this is a fourth of the data. And then the middle is 1/2 of the data. And this middle point is exactly your median. Yeah, I believe the fourths are inclusive. So this is just by definition of how the box whisker plot works. But you could have also gotten this question right by just process of elimination. Okay, between which consecutive integers is 29 over 7? So what's 29 over 7? The way that I would think about this is I would think about the closest number that is close to 29 that is divisible by 7. And that value is 28, right? So 28 out of 7 is 4. So I know that this value has to be greater than 4. So I know that it's between 4 and 5 because I know it has to be greater than 4. So it can't be these. And it's not greater than 5. So this is our answer here, C. Okay, now let's tackle this word problem, which seems like it's going to be long. So a customer wants to buy a price of hiking boots. They're telling us that the original cost is $85.75. And then the store is offering 15% discount. And then the customer has an extra coupon for 25% off. And then we have to pay tax on it. Okay, and then we see that we're not even so lucky because all the numbers are very close. So there's going to be periods of time where you actually have to be careful with your arithmetic, and there's going to be periods of time where you can estimate. And I usually look to the answer choices to guide myself on if I'm able to estimate or if I'm able, or if I'm going to have to spend the time and be careful with my arithmetic. And you see the differences here are like in $4, here it's just in some cents. So I have to be really careful because I have to get an exact answer for this question. Okay, so let's start thinking about how we're going to tackle this. So first, I'm going to get 15% off, right? So I'm going to say, well, 85.75, I need to take 15% off that, and I need to subtract it from 85.75. So I'm going to have 85.75 minus 0.15 times 85.75. And then I'm going to get a sale price. So that is step one of what we would have to do. So another way of thinking about this is like, these are kind of like terms, right? 85 and 75, and there's an invisible 1 here. So basically what I'm doing is I'm getting 85% of 85.75 because it's 100% minus 15% off. So it's just 85% of that. So that's another way to do it that can save us a little bit of time here. So you would do 0.85 times 85.75, and we would get that is approximately $72.89. So I'm rounding this because it's actually like 8875, but since we're dealing with money, we can round. Okay, so once we get there, now we do 25% off the sale price. So now I have to do 25% off from 72.89. So basically I need 75% of 72.89. And that's going to give me $54.67. But now I have to add tax. So now I have to get tax. So now I have to do, well, 54.67 plus 0.085 of 54.67 to get the final cost. And I can't really eliminate anything. So I still have to do this final math. And that's going to give me my final answer of 59.32. So again, with certain ones, I really encourage you guys to use estimation, but then there's certain questions where you can't. And this is the kind of question that we save our time for, because this is going to take a lot of time to sit there and multiply that out. Where did this 85% come from? So 15% off, right? So that means I start with 100% and I need to lose 15%. So instead of doing 15% and then subtracting, you can just do the subtracting first and just get 85% of the total. Does that make sense? And same thing here, instead of doing 25% and then subtracting, you can just do 75%. And honestly, even same thing here, instead of doing 8%, 8.5% and then adding, you could have just done 1.08 times 54.67. And that would have saved us time as well. But if you're uncomfortable with that, you can 100% do 15% and then subtract. So the key here is whenever you use discounts, you subtract because you pay less. And whenever you pay tax, you add because you pay more. So with tax, you're going to be greater than 100% because you're adding. And with the discounts, you're going to be less than 100% because you are subtracting. Okay, let's see. Let's try to finish these last 4 and finish strong. And we have about 10 minutes left and save some time for questions at the end. So we have Sheila saving money for her summer vacation. She starts the summer with a balance of 90 and plans to save 15% of her earnings each week. She earns the same amount each week. After 12 weeks, she saved this amount of money. And the question is, how much does she earn each week? Okay, so what we have is she's starting with $90, right? So that's our start. And then she wants to save 15%. So 15% as a decimal is going to be 0.15. And she wants to save 15% of what she makes each week. So she works for 12 weeks and I want to know what she makes each week. So that's going to be my X. And altogether that she made a total of 472.59. So the hard part is writing the equation, and then we just have to solve it. So again, we just want to get X alone. So I'm going to subtract both sides by 90. We're going to get 0.15 times 12X is equal to 382.59. And then 0.15 times 12 is going to give us 1.8X. And then again, we have to divide by 1.8. And we get our answer here, which is 212.55. Now, again, this one is a kind of nasty one in terms of arithmetic. There's not much that we can do. All the answers kind of end with 55, so we can't really use the units. And there's not so much space to estimate because the answers are still pretty close together. So this is one that I would argue that you actually have to do this division. And again, another one that you can't really estimate on and save time. This one is just a proportion. So I want you guys to know that colon is similar to just a line. So it's like a proportion. So this is the same thing as saying X out of 35 is equal to 20 out of 28. And I also want you to know that you're allowed to simplify within the proportion, right? So you can divide both of these by 5 and get 4/5 here. And then you can see that the relationship here is times, sorry, not 4/5. You can divide both sides by 4 and get 5 out of 7 is what I meant. And then you can see that the relationship here is times 5, which means the relationship here is going to be times 5 and X is 25. Similarly, if you don't want to do that, you can go ahead and cross multiply. But again, if you cross multiply, I don't want you to spend time and say 35 times 20 is equal to X times 28, and then sit there and multiply 35 by 20. You don't need to do that. You can just divide by 28 by both sides, and then you can simplify here because these are both divisible by 7. And then these will divide into themselves too, and then you still get the answer that way. So multiple strategies, whichever one you go though, do not waste time on arithmetic. So I'll put that in red. So try to save time on arithmetic. Okay, let's keep going. I think we can do these 2 questions and then call it a day. So this one we already went over. So remind me again, what do we do for order of operations? Yeah, PEMDAS, right? So in this case, we have parentheses. So we're going to start with parentheses first. So somebody simplify the parentheses for me in the chat. So 3 minus 8 is -5, and -5 plus 2 is going to be -3, right? So we're going to have within the parentheses -3, and then the squared stays. So we did parentheses. So next we're going to do exponents. So up top we have 3 squared. So that'll simplify to 9. Then we have -8 squared. So that'll simplify to 64. And then 2 squared, which will simplify to 4. And then on the bottom, -3 squared simplifies to 9. And now up top, let's go ahead and add everything. So 9 plus 64 is 73, and 73 plus 4 is 77. So we have 77 over 9 as our answer. Okay, and then last one, we have a soccer coach purchased 15 pairs of cleats for team members and spent a total of $805.95, including tax. If the tax rate is 8%, what is the price of each pair before tax? So this is kind of making us do the opposite of what we did in the question before. So we know that the total cost is $805.95, and that includes the 8% tax. So that means that it's 108%. Does that make sense? So 805.95 is equal to 1.08 times X, and X is the original price of all the things before the tax. Does that make sense? So X is the cost of 15 cleats before tax, because the tax is an extra 8%. So it's 100% of the cost of the cleats plus an 8%. That's where this 1.08 comes from. And then again, the arithmetic is kind of not in our favor in this case, but we have to sit there and do this kind of nasty division of 805.95 divided by 1.08. When you do this division, you get 746.25. But be aware that this is the price of all 15. So the last step is that we need to divide this by 15. So 746.25, we need to divide that by 15. And that's going to give us our answer of 49.75. I think in this case,
I think we're at 8.
Yeah, this is the last question. We're just finishing.
So we'll just finish up this question. Okay.
Sure. So in this case, we could use the division trick, right? Because 5 and 5, we know that this is going to end in 0.75. Okay, guys, so just some takeaway of everything that we covered. So let's just scroll through the notes that we took together. This is absolutely imperative that you guys rewrite these notes, that you practice these notes. I would say that we reviewed all of this so we can put these nice check marks off on our goals list. Please, please, please review all of these notes. These concepts are definitely going to come up. All of these formulas you guys are expected to know, and memorizing the triplets, the special right triangles, memorizing these formulas, and the commonly used decimals, fractions, equivalents, as well as the squares. All of that is going to take your performance to the next level. And then just to review all the strategies we talked about, so using the units digit rule, being able to estimate your answer in some cases to save yourself time to do those questions with the nasty arithmetic that you can't estimate, all of that is going to take your performance to the next level, and simplifying whenever you can. Don't do any extra work, okay? All right, so you guys will have these notes. I'll send them to Mrs. Kweller and she'll send them out to you. Does anybody have any questions for me before we wrap up?
Everyone, let's take a moment to give Olga a proper thank you. If you could open the chat so everyone can communicate with you. Everyone, let's give Olga a huge, gigantic thank you. I will begin because this was such a big deal that you are going strong, and you're going strong through tomorrow. So let's say thank you. Thank you. Everyone, let's give Olga a huge thank you. All right. Cool. Who wants to see my cute little doggy? Okay, Goldie, come here. We want to see you. Let's give Olga a huge thank you. Ready? Goldie, look at this. Hold on, guys. I'm giving you the dog. Wait. Goldie, say thank you. Everyone, the dog is about to say thank you. Thank you. No, I'm kidding. Okay, Goldie.
If you want, you can spotlight Goldie. It's up to you. But I feel like she's a little more entertaining. Everyone say thank you to Goldie. Goldie, hello. Everyone, thank you so much. Something that I definitely want to do, and I love ending the webinars like this. Let's take Olga right now. We're going to take everyone off mute, okay? And we're going to say thank you. Okay, so everyone, I'm going to go to the participants right now, and we're going to unmute everybody. Ready? We're going to count to 3. If you could all please unmute yourselves. We're going to count to 3. Ready? 1, 2, 3. Thank you.
Thank you.
Thank you.
Thank you.
Thank
So
you.
much.
you.
Even I learned math
Thank you.
at 41 years old. So thank you, Olga. Thank you, thank you, thank you, thank you. Who can say the most thank yous in 10 seconds? Ready, set, go.
Thank you.
Thank you, thank you.
Thank you. Thank you. Thank you.
Thank you.
So much. We really need it.
Okay. Thank you. Tomorrow, grammar. Okay, we're ready. Bye, Olga. Have a wonderful night. It is 9 p.m., 2 hours of math later. All right. Thank you, everyone. Have a good
Thank you
evening.
guys. I'll see you
Bye.
all
Thank you
tomorrow
so
for grammar.
Bye.
Thank you,
Thank you.
everybody.
Bye.
Wow, look at all
Thank
these
you.
faces.